I love solving problems. As a kid, math problems, and now probably water crisis. So when I was a kid, I used to see the Star movies, for example, and I used to see those kids drinking from tap water, and I used to think, what's wrong with these kids? How can they drink water from tap water? They don't have a filter, or what's wrong with them? Later on, when I grew up, I realized that they have really clean water and we don't. And it's probably been 15 years from then, and we still don't have that kind of water facility in India, which is quite sad, frankly speaking. So today I'm here to discuss about water issues in India and how we are trying to solve it. I'll divide this into 4 sections: the problem that exists and what exactly is it that we are trying to solve, the reason for it to exist and why haven't anyone else solved it before, the solution that we have, and the need for doing this, and why don't we make an internet firm instead of doing something like this. So let's start with the problem and why is it this bad. So the first category of people who we are trying to reach is the kind of people who don't have access to piped water itself. So we take water for granted. Developed countries take pure water for granted. But there's a very large section of India, as much as 1/3 of 2/3 of rural population who don't have access to water. They have to go to regular ponds or river, which is not very clean, and which obviously causes diseases. There's a lot of mineral issues, and you have to walk a long distance to get that water. So a lot of times those are students, children. Instead of going to school, they basically try to get water, which isn't very cool. This results in a lot of deaths. A lot of children die out of dehydration because of minerals. Out of diarrhea is a very curable disease, but a lot of people get it because of waterborne diseases, which is a big problem. But even beyond that, even people like us who have piped water, we also have a problem. If you've ever been to IIT Bombay, there's a pipeline that goes right next to the boys' hostel. So if you go there, you can see a lot of cracks on it. There's a lot of sewage water that seeps into the drinking water. And this is not a rare issue, this is a very big problem. In February this year, in Noida, there were about 3,000 families who suddenly fell in within a week, including children. This was because apparently their drinking water was being mixed by sewage water and they were forced to drink it for a month. So that is a big problem. Even though we've spent so much money on this kind of issues, this has been existent for many decades now, which is quite shameful. The third category of people that we are focusing on is the drought-affected areas in Maharashtra, in Latur area, in Andhra. So this is the primary go-to area where we want to start, because they have Latur, for example, doesn't have pipe. It has pipe, but it does not have water. That is such a big problem. 29% of the reservoirs don't have water. So that is a big problem. Yeah, right. So the reason for this is basically mismanagement. Delhi has Yamuna and stuff. So this is there. So this is the availability of water. India is very low in availability. After independence, we gave free electricity to the farmers. They started depleting the groundwater very quickly. So unlike other countries, this has gone down and this is going down very rapidly, which is a bad situation. If we don't have enough water per capita, then obviously it's not a good situation to be in. In India, there's only 2 cities which has 24/7 water supply. Others, we know we don't get 24/7. We have only a few hours. In Delhi, for example, you have places where you get only for 3 hours a day. So we would like to see water being available 24/7 of the time. Another main reason is industrialization and farming. In Delhi, for example, we get a lot of our water from Yamuna, which is basically black and really you can't drink in it. We have another source, Panipat, the river that comes through Panipat. Unfortunately, there's a dye industry, there's a lot of clothing industry in Panipat, and they often put discharge dye into the water. and that renders the drinking supply of Delhi non-existent. So that is a big problem. So as you can see, the irrigation takes a lot of water. Second problem is thermal power stations. They use a lot of water, and usually they don't have a meter. So what they end up doing is they use a lot of water unnecessarily, and this reduces the available water that consumers would have. So we need to change that also. We ourselves are problem. We dump a lot of dirt in the water. The dead bodies are prohibited, and still we look for other means to dump those. Then another problem is mafia. For example, in Delhi we pay at least 2x the price just for daily use of water, because we don't get water. We have to go to these tankers or any other people. Now these people, they go in the night, and they use either dams or well or whatever it be, and they take water out from there and sell it in the daytime. This also destroys the groundwater. So that is a bad idea. If you have enough water, then we can probably do a better job of controlling the mafia. So there are enough solutions. We could desalinate. We can use desalination plants. Like Israel is the biggest one. There's one coming up in California where we take seawater and remove salt out of it. But that is a problem. It uses a lot of energy to do that, and it uses a lot of electricity. So that's a bad idea. You can't produce a lot of water that way, and the biggest challenge is not every place in the world has a seawater access. So you need to solve that. Like for example, Delhi will not have, will not be able to solve that. So this is where we come, where we solve this exact problem. So we produce water using processes that have zero emissions. We do not use electricity from the grid, for example, or we do not burn fossil fuels. So it is a completely zero emission process. It is inexpensive. We can be as cheap as tap water. We don't have to be very expensive like Bisleri or any of that. If you go to Latur, you have a lot of these Bisleri bottles you'll see all around. So these are from secondary markets basically. They refill those bottles and sell. So that is a bad idea. We can generate at very high volumes, and it is reliable and closer to the people who go to the consumers. So it reduces contamination, and it reduces the infrastructure cost that needs to be there, and it is safer. So this is how we make it. We have an engine basically, and this is how it operates. So this is basically how it does. So in this, the engine that you just saw is our engine that we use. We use low-grade heat from sources like thermal power plants, hot water, or from a restaurant's exhaust, or even vehicles' exhaust for that matter. And we have a special thermodynamic cycle, which is sort of similar to Rankine cycle. And it produces electricity generally. We can basically run a turbine which produces electricity. In a different mode of operation, we can produce less electricity, and the byproduct of the process, of this whole thermodynamic process, is water. So we can change the whole dynamics and produce more water and less, almost negligible electricity. We had started this as a rural electrification program. So, this is one mode of operation. The another byproduct is cold air. So if this is in rural area, for example, we can connect this to a silo and produce cold storage systems. So at very cheap rates. And this is the turbine, the rocket that produces this. So if you see, this is the water being produced. This does not have a canister. Turbines have perfect casings in some microns distance. So that would produce a lot of water. And a lot of water is being spent on into the atmosphere. So this would produce a lot more water than you can see right now. And this is the energy consumption. Generally, you spend a lot of energy to produce water. If it's not from a freshwater system like a lake or a river or whatever it may be, we consume very less amount of energy. We can even use solar power. We can just connect 4 solar panels, for example, and generate water. So there's no cost of energy. We don't need a source of water also, like lakes or anything, since we use humidity from air to generate water. we cool it down and use deliquescent materials to pull water out of it. So this is there, and we are also very cheap to generate water, since we do not require. We are not dependent on other quantities. We do not have logistics. We do not have energy considerations, and we don't need a continuous supply of water. So that makes us very inexpensive. We do not need, like at MIT, there's been research for artificial photosynthesis that uses ruthenium core. Ruthenium is very expensive. Beyond lab scale, that's not very possible. So we don't use we use pure aluminium to build our engines. So that basically makes it cheap. It has a long lifeline of 20 plus years. So maintenance is cheap, and in the longer run, it comes to be cheaper than tap water. And why are we doing this? There's a Japanese concept called ikigai, which means everyone comes on earth for a certain purpose. And we think this is our purpose, to solve the bigger problems that the people on earth face. And probably your ikigai is to help people like us do something that we want. Questions, please. Yeah.
I'm still not clear on your product. Is
Right.
it going to be a mini plant, or is it going to be a system that you install in a console?
Yeah.
And what is the capacity, generation capacity going to be like? What speed you can generate?
Right.
How much can you serve out of the unit?
Right.
What's the unit and what is the capacity?
So we started out as a energy company where we generate electricity. So how we see ourselves is as per kilowatt hours, with our capacity. So we can generate as much as 20,000 liters on our prototype right now per day. But as with DG sets, you see DG sets in your home and on multi-megawatt level. So we can upgrade them depending on the need. So we are not in a home or offices, probably a little over that. And we can go right up to the plant level, where our aim is to generate water for villages or communities, but not for home. That would be very expensive for us.
Yeah, but so you also generate electricity. The main product that gets generated is electricity. Byproduct is
So far it was electricity. If we can choose to generate almost no electricity and instead focus it on only water generation. So the electricity, how it works is basically we have an engine, and that engine, it takes low grade energy from whatever source it is, and it converts that into power, electricity. So the byproduct of this, it uses air as a heat exchange fluid in the engine. So and air has water in it, humidity. So one of the byproduct, we cool it so much at minus 55 degrees that water comes out. So that is a parasitic loss. We don't want that happening when we are generating electricity. But what we can do is, instead of generating electricity, we can cool it down to minus 55 degrees, which generates water. So far we've generated 20,000 liters per day. So this is like, we were just testing it. This is not the final product. We know we can generate much more than that. The only condition is we need to check the mass flow rate of air. So the production depends only on the mass flow of air. And like DG sets, we can scale it up. So that shouldn't be much of a problem. Scaling down might be a problem. We wouldn't want to produce water for one home. So
what's the operating cost like to generate 20,000?
right now, for a month, we've been spending about 2,000 rupees during the whole month. For operating, we use solar. There's nothing else that we require. So the 2,000 rupees is basically the working fluid that we have to buy, and the solar trough. 1 meter square. We built this for 40,000 rupees. If we have a production of more than 100 engines, then we can definitely produce it at about 30,000 or less.
40,000 rupees investment and 20,000
Per day. Yes. This is distillation grade water. So we don't have any microbes in it, we don't have mineral issues that water generally has. This is pure water basically.
So I have two questions. What is the humidity range you can operate?
Right.
Like air.
Right.
Is a free air or is it compressor? Mainland.
How does the motor run? Okay. So the air is the regular atmospheric air. We don't process it. We don't do anything to it, and we can theoretically we can go for as much as 10% humidity. Because we are going to minus 55, we basically produce ice and not just water. So the humidity shouldn't be so much of a problem. Even in, for example, in sub-Saharan Africa, there's a company which uses a delicate material, and the billboards that you see on the roads, they have a meter long tube full of that material, and that produces water enough for those villages there. So we are pretty much doing the same thing, but we are doing it at minus 55 degrees. So if they can give water to a village using that, we are sure we can do much better at whatever the humidity level is there. So that shouldn't be a problem. If we were at say 4 degrees or 5 degrees, then we would probably worry about the humidity. But at minus 55, humidity should not be a problem. And if you have a humidity level that low that we can't take it out, then that would we can't survive in that kind of environment either. So we wouldn't probably be working in that kind of situation anyway. So yeah, let me just. Okay, so basically we use low grade. So how Rankine cycle works is basically you have a working fluid like water, and you give it heat, and where it converts into gas, superheated steam. That gas then drives the turbine. So similarly, we have a working fluid which is a proprietary fluid which does not have carbon in it, and so we heat it with low grade heat. Anything that is above 2 degrees Celsius but below 130 degrees Celsius. So this then superheats our gas. The characteristic of a working fluid is that its coefficient of heat expansion is a function of temperature. So if you increase the temperature, not only would it increase in volume, it would the rate of expansion itself would increase. So the increase. So that's pretty much an explosion. We use this property at 130 degrees to go from 8 psi directly to 2800 psi. And this then runs our turbine, the one that you just saw. And this is a turbo generator. So there's a generator directly connected to it, which generates electricity. Once the spent working fluid, so in Rankine cycle, the biggest issue that anyone ever has is what do you do with the spent steam? So either you let it go into the atmosphere, which is spent water. Now you need continuous flow of water, which is expensive. Or you can regenerate it by cooling it. Now for cooling it, you have to bring down the temperature and compress it. And compressing any gas is a very stupid thermodynamic process because there's a lot of heat that goes out, which you cannot use. So there's as much as 60 to 80% parasitic loss just because of that in today's thermal power plant. So instead of mechanically compressing it, we use electrocatalysts. So which basically uses electricity at about 2 volts with catalysts to convert the spent working fluid back into the liquid. Obviously it takes energy, but it's much lesser than mechanical compression. So this I think you'll probably understand being a chemical engineer. So this is a continuous process. So this is what we are employing, and this is one of our key proprietaries. So yes, we have 3 prototypes ready. We are making our 4th one right now. Not yet. But we are working. We are also working with Indus towers, telecom towers to power the telecom towers. So yeah. Right. So we haven't tried the solar yet. We've just started. The 20,000 was from solar. We are also our factory that we are also trying to use heat recovery there. So they have a very small furnace. So we probably would want to try that. So the 4th prototype that we are building is going to be using heat recovery. And we are also in talks with the Indraprasth power plants. So they have big gas turbines in Delhi. So we can also, since they don't have access to natural gas, they've been operating at 1/6 of their operational capacity. So they're sort of interested, their solar division. So we are in talks with them since a month and a half now. Yes. The base chemical that we start is very widely used chemical in the chemical petroleum industry. So it's basically a based compound that we have.
But you make it or you buy it? What do you do?
We buy it and then we enrich it into
Buy
a,
it.
yeah.
There is no import.
No, there's no import. Even India generates the basic.
Is it only in Africa? It's the same model you said?
It's not the same model. The only thing is they use a simple deliquescent material, and so far they've just tried in a few villages.
Have you looked at the slingshot